Welcome. This video is going to go over solutions to the Chapter 6 practice quiz on kinetics. So number 1 says, consider the reaction between solid calcium carbonate and aqueous HCl. And it says the reaction will be speeded up by an increase in which of the following conditions. So 1 says the concentration of HCl. So that would speed it up because increasing the concentration means you're going to have more particles in the same space. 2 says the size of the CaCO3, and what you have to notice here is it says an increase. And increasing the size doesn't help the reaction rate. That actually would slow down the reaction rate because remember you want more surface area or smaller pieces. And then 3 says temperature, and an increase in temperature will always speed up your reaction rate. So we have yes, no, yes. So that means B, 1 and 3 would be my best option. Number 2 says, in the Haber process for the synthesis of ammonia, what effect does a catalyst have? And this is a good example of IB giving you a distractor because you can really cross off that whole in the Haber process because it doesn't matter. In any process, a catalyst has the same effect. A catalyst always increases rate, but remember it increases the rate of both the forward and the backward reaction, so the amount of product made isn't going to change because again, the backward reaction is going to undo that product just as quickly as it's being made. So my correct choice would be C. Rate of formation increases, but there's no change in the amount or yield. Number 3 says the reaction between ammonium chloride and sodium nitrite in aqueous solution can be represented by the following equation. So you notice you have 2 aqueous reactants. You're going to end up with a gas, a liquid, and an aqueous solution being produced. And it says the graph below shows the volume of nitrogen gas produced at 30-second intervals from the mixture of ammonium chloride and sodium nitrite at 20 degrees. And this is a pretty classic looking reaction rate graph based on product. It's the volume of N2 that's being measured, which is one of the products. So it says, state how the rate of formation of nitrogen changes with time. Explain your answer in terms of collision theory. And you'll notice this is a 2-mark answer. So the rate of formation changes, it decreases over time. Okay, from the beginning, the rate decreases. The slope immediately starts getting less. So that's the first thing they want you to know. And in terms of collision theory, that makes sense because there are fewer reactant particles to collide. Part 2 that says, explain why the volume eventually remains constant. Now this one's a little bit tricky. When you look at the picture, that plateau doesn't continue on. So, and if you look at the equation only used a single arrow. So this one is indicating with the single arrow that the reaction went to completion. Okay, so you've used all your reactant up. If there was a double arrow and the plateau continued, then we would assume it was at equilibrium. But in this case, the reaction has gone to completion. Part B asks, state how the rate of formation of nitrogen would change if the temperature were increased from 20 to 40 degrees. And this is just 1 mark, so simply knowing it would increase is fine, and it only says state, not explain. You might have also noticed that it increased by 20 degrees, and the assumption is that for every 10 degrees it would double. So this would actually quadruple the reaction rate approximately. So if you knew that, bonus points for you, but increase would be enough to get you your 1 mark. Number 2 says, state 2 reasons for the change described in B1 and explain which of the 2 is more important to causing the change. So when you increase temperature, you increase the frequency of collisions, and you also increase the energy of collisions. And the one that's more important by far is the energy, because it doesn't matter how many collisions you have if they don't have activation energy, the minimum energy. So by far the energy is the more important of the 2. And then part 3 relating to the same reaction says the reaction between solid ammonium chloride and aqueous sodium nitrite can be represented by the following equation. And remember now you've changed from aqueous ammonium chloride to solid. And it says state and explain how the rate of formation of nitrogen would change if the same amount of ammonium chloride was used as large lumps instead of as a fine powder. So large lumps is going to decrease the rate. And the reason why is it's going to be less available because of this decreased surface area, which means there's going to be fewer collisions. Number 4 asks, which statement is correct about the behavior of a catalyst in a reversible reaction? So you have to remember, you should have this little image in mind. It doesn't matter if you're thinking exothermic or endothermic, but a catalyst brings this area of the graph lower. So it decreases the activation energy for both the forward and the reverse reaction. So the enthalpy change, however, the difference in energy between bond making and bond breaking, this stays unaffected. So A says it decreases the enthalpy change of the forward reaction. It doesn't affect the enthalpy change. B, it increases the enthalpy change of the reverse. That's not true. B, it decreases the activation energy of the forward reaction. That is true. And D, it increases the activation energy of the reverse reaction. That's not true. It also decreases the activation energy of the reverse reaction. So only C is a true statement. Number 5, which statement is correct for a collision between reactant particles leading to a reaction? Colliding particles must have different energy. No, there's no requirement for that. All reactant particles must have the same energy. No, that's not a requirement either. Those two don't matter. They can have the same or different energy. It's the idea that they have to have that minimum amount of energy, which is what C indicates. Colliding particles must have a kinetic energy higher than the activation energy. That's true. Colliding particles must have the same velocity. No, that's not required either. So only C is a true statement for reactant particles colliding to form a product. Number 6 says the table shows the concentration of reactants and products during this reaction. And I can see I have a 2-to-1 ratio in my reactants and a 1-to-2 ratio of my products. And then it gives me all my beginning amounts. I have no product to start with. And then after 1 minute, my reactants have decreased in concentration and my products have increased. So the rate of reaction can be measured by reference to any reactant or product, which rates are correct. So 1 says minus 2 moles per decimeter per minute for A. So if I take my concentration after 1 minute is 4, my beginning was 6, I divide by a minute, I do get minus 2, so that appears true. Minus 1 mole per decimeter cubed per minute for B. 2 minus 3 over 1 gives me minus 1, so that's also a correct statement. And minus 1 mole per decimeter cubed per minute for C. And right away, the minus tips me off that this isn't going to be true because I'm making products. So I should actually take 1 minus 0, divide by 1. So this should be a positive 1 there. So 3 would not be considered a correct rate. So only A would be true. Number 7 says at 25 degrees Celsius, 100 centimeters cubed of 1 molar hydrochloric acid is added to 3.5 grams of magnesium carbonate. If the sample of magnesium carbonate is kept constant, which conditions will not increase the initial rate? So remember, I had 100 centimeters cubed. I'm just going to write that up here. And it was at 1.0 molar, and it was at 25 degrees. So what conditions will not increase it? Well, as I look down, C will increase it because you've increased the temperature to 35. So that one I can cross off. The concentration, if I increase the concentration to 2 moles, that's also going to increase it. Because more concentrated is going to make collisions happen more frequently. So it appears that A is my only possible answer. And the only change there is that I've doubled the volume of HCl. And that's true. That does not increase the collisions because it simply gives you more HCl over a bigger area. So the reactant particles aren't packed any closer when you use double the volume, so there won't be any increase in collisions, so there's no increase in rate. And then number 8 says excess magnesium was added to a beaker of aqueous hydrochloric acid. A graph of the mass of the beaker and contents was plotted against time, so apparently a gas is being produced and allowed to escape. And it says what change in the experiment could give line 2? So line 2 is a faster rate. So what would speed up this reaction rate? And A says the mass of magnesium in smaller pieces. Now, normally, that would seem like a good thing to increase the surface area. But in this case, it's not going to make a difference because magnesium was already in excess. B says the same volume of a more concentrated solution of hydrochloric acid. That would make a difference. That would increase the rate because now I've got more hydrochloric acid reactant molecules in the same space. C, a lower temperature, that's going to decrease rate. And D, a more accurate instrument to measure the time, that's not going to affect the reaction rate. It might affect the quality of my results, but not the actual rate. So B would be the correct choice.